Good afternoon again, and welcome to becomeatechpro.com. In today's session, we want to look at Linux. In the last session, we were able to start with the reasons why we learn Linux. We also looked at the requirements for setting up a Linux environment. We went further to set up a virtual machine on AWS, and we looked at the different tools that are required, right, for accessing and managing resources on the Linux server, right? So we do not need all of this. We just need to understand that there's a secure shell client and there's a file transfer protocol client that can be used, okay? So for all of this, you just need one to make it work, or two, depending on how it goes. You don't need to have everything installed. You just need one to be able to access your remote computer, okay? Now, for file transfer protocol, can look at SCP commands, right? We'll get to look at it as we start with Linux commands, okay? So right now, if there's any command we've run, okay, it is not sufficient to think that, oh, those commands are all we need to learn, or we can take it that those are just considered bonuses because we've not actually started learning Linux commands, okay? But in the course of setting up, I had to use some Linux commands. That is why I use them, and I try to explain what they are all about. But we'll learn Linux proper, right? We'll learn Linux commands proper. So whatever we've learned before, let's just take it that they are considered bonuses when it comes to commands, okay? So we've seen the tools that can be used, okay? We've seen the different tools. Then we've also gone ahead to look at the history of Linux and also looked at the features of Linux, okay? We've looked at the difference between licensed and free and open source. We'll be using this open source a lot in the course of this program because most organizations consider open source, right? Because they can be modified to suit their requirements. Aside that, most of the open source applications are also free. So we have the concept of free and open source. So organizations are looking to cut down on their costs. They're also looking at making the applications robust for them. Okay, so that's why they go for open source applications. Okay, now looking at that, where we stopped, we talked about Linux distributions. Okay, so Linux distributions, we've looked at them at a point when we're trying to set up a virtual machine, right? After choosing AWS as our cloud provider, we went further to select, after choosing AWS as our cloud provider, we went further to select an instance type, right? T2.micro was what we selected. And we also looked at the fact that we needed a certain distribution. We saw Red Hat, we saw Ubuntu, we saw Amazon Linux, okay? So based on all of that, so let's look at Linux distributions, okay? So Linux distributions are the versions of Linux that have been created by different organizations or different parties, which can be distributed, right, to others for others to use. Okay, remember we said Linux is open source. So some people have gone ahead to look at these applications and they've gone to modify them to their own requirements. And also they are distributing these applications. Okay, so those are distributions. Okay, they can also be called flavors or distros. Flavors or distros. Okay, you can see distros, right? Can call them flavor, just as you have ice cream. You can have strawberry flavor, you can have vanilla, you can have all sorts of flavor, right? Flavors. So we call them flavors or distros, okay? So an example, let's take a look at Ubuntu. Ubuntu is an example. Ubuntu is an example of Linux distribution, okay? So it's a very popular distribution for use in both personal and business cases, okay? So this is Ubuntu. Now, we also have Red Hat, which is the one we installed. Remember, Red Hat, okay? Red Hat is the one we installed. So Red Hat is a leading provider of open source solutions, okay? As we go on, we'll see other applications that are also provided by Red Hat, okay? We'll get to see them. So it's also known as Red Hat Enterprise Linux, okay? Okay, so we have that Red Hat. Okay, so we've seen this. Okay, so it's called distros. You can see distros or distribution. Okay, they are like the flavors of, as we mentioned earlier, ice cream like vanilla. So just as you have that, you have oh distros of Linux. You can say you have Ubuntu, you have Red Hat. Okay, there's also CentOS, okay? The CentOS. So CentOS is derived from Red Hat servers, okay? Red Hat Linux. So CentOS is derived from the code base of Red Hat. It's open source. You can just pick one of them and tweak, right? And create your own distribution, right? That is something that is also possible, right? So CentOS, for example, was built out of the code base of Red Hat Linux, right? You can see. When we're also checking, I remember we saw SUSE Linux, okay? SUSE Linux is also another example. SUSE Linux, okay? So this is for enterprise level. It has enterprise level features, right? For enterprise customers, right? So it's focusing on enterprise customers, right? Not the regular normal users, just business use cases, okay? SUSE Linux, okay? Then you have the Debian, okay? Debian, okay? Debian is also very popular, okay? And it's from Debian. You have distributions like Ubuntu, right? Remember, we said CentOS is a breakout of this, right? It's built from this code base. Also, you can say is Ubuntu is in the same class with Debian, right? It's Debian is the basis for Ubuntu, right? And many other distributions. Okay, so that's Debian. Okay, we can also have Slackware. Slackware. Slackware is one of the oldest. Okay, Slackware. Okay, Slackware. We also have Fedora. Fedora is an open source distribution, Linux distribution, and it was sponsored by Red Hat. You can see. Let's even put them together. You can see those that came off Red Hat, sponsored by Red Hat, right? You can see. It's also sponsored by Red Hat, okay? So it's also it's well known um, for its commitment to open source principles, okay? That's Fedora, okay? There's also Gentoo, okay? We also have this. We also have Mandriva. So you don't need to memorize all of this. They are all over there on the internet, okay? So, but we are just mentioning them so that we'll have an idea of what distributions are, right? Because you might not find a resource where you'll have everything compiled together and you get an explanation of, okay, because sometimes you see that there are some commands you run on CentOS that you also run on Red Hat, right? And you also run on Fedora. It is because these were built out of Red Hat code base, okay? So sometimes you see that they will classify Ubuntu, they'll say, oh, Debian / Ubuntu distributions, right? Because they are using, you use the same, they are using similar code base, so they are working in a similar fashion, okay? So there's also another one that is based on Ubuntu. Let me take that up to where Ubuntu is, okay? There's also another one that is based on Ubuntu and it's called Mint, okay? It's also based on Ubuntu code base, okay? It's easy to use and user-friendly, okay? So this is the one we installed, so Red Hat, okay? So we have a server, we have a Red Hat server, okay? That we have a Red Hat Linux distribution on it, right? So that is it, okay? So that's that on Linux distributions, okay? So that's a list of the Linux distributions we have, okay? And there are several, many more, okay? We can't list them all, okay? So even you can, at a point, create your own distribution out of an existing distribution and improve on it. It's open source, right? So nobody can say, oh, don't work on it, you know? That's the same way Linux itself was created, right? It was created based on a certain need, right? So that's that. So let's look at text editors, okay? So for example, if you look at my, let's see, if you look at my Windows computer now, I can search Notepad, right? I can search Notepad. So Notepad here is a text editor, right? Notepad here is a text editor, right? So just as I have Notepad, right, in my Windows computer, okay? So I'm sure we are all familiar with one or several types of text editors. For those using Windows, we've seen Notepad++, right? For those using for Windows, right? Right, for Windows, we've seen Notepad++. And for those using macOS, I'm sure they've seen TextMate, right? For macOS. And they've also seen, for macOS, they've also seen WordDoc, right? For macOS. But for us, we are working with Linux, okay? So there are certain text editors we'll be working with, okay? For the sake of Linux, okay? So we'll be seeing the text editors as we start, but just for us to make a note of them, there's one called VI, okay? Okay, there's VI, there's Vim, okay? There's Nano, okay? All of these are for Linux, okay? So you can see, just as we opened a text editor on the, where's it? I've closed it. Okay, just as we opened the text editor on the Windows computer that I have, right? You'll also be able to open text editors on Linux servers, okay? And the different text editors, popular text editors we have are Vim, VI, Nano, you see. So these are popular. So usually this comes with the server by default. Okay, this comes with the server by default. For this Vim, you need to install it. So Vim and VI, they look similar, except that Vim has some coloration, has some special look to it. Okay, that's just the difference. But this one, you need to install it. Okay, but VI will come by default with our Linux server. So when we get there, we'll see how to use it. It's not difficult. It's like just the way we are typing right here on this our VS Code. But this that you are looking at is VS Code that is called VS Code. It's integrated development and IDE tool, right? Integrated development environment. Okay. So usually developers use something like this to write their codes and all of that. But right now, I'm not doing any of those. I'm just using it as a text editor. Okay. So apart from all this VI and all of that, so there's also VS Code, as we've seen, right? VS Code, VS Studio Code, okay, VS Code, Visual Studio Code, okay, so that's made by Microsoft, okay, so this VS Code, okay. There are also other ones, right, that we can also look at. There's Sublime, okay, there's Sublime Text. Other examples, Sublime Text, there's Sublime Text, okay, there's Sublime Text, there's Sublime Text, there's Atom, and just so many of them, but we'll be concentrating on this, right, for the purpose of our work, okay? Vim, VI, and Nano, okay? So if I'm not using macOS, I'm not bothered about what 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 doc or TextMate is, right? So I'm only concerned with what I can use, okay? So I won't bother myself with what I'm not using, okay? So that's fine. So looking at this, we've been able to look at different text editors. So now we want to look at the different users in Linux. The different users in Linux, okay? So we'll be looking at the three different users, okay? The first user is root, okay? That can also be referred to as admin or super user, okay? You can see these are just synonyms, right? Super user, okay? So it could be a root user, it could be an admin user, or it could be a super user. So the other one we can look at is the normal users, okay? We'll talk about all of this so we can have a better understanding of who they are and what they are capable of doing, okay? And the last one is system user. If you recall, when we wanted to create our or log into AWS, take a look at this. You see something like this, root user, root, okay? Account owner that performs task requiring unrestricted access. That is a root user. I am user within an account that performs daily tasks. You know the interesting thing about this course is that although for us, we are new to it, right? But as we go on, we realize that everything we say, right, there's already an answer for it somewhere, even without having to rack our head. The answers are just everywhere for us, right? You can see root user. It has told us who a root user is, an account owner that performs tasks requiring unrestricted access, right? I am user, users within the account that performs daily tasks that has been created by usually the root user, okay? So now back to our table, right? Our list. We have normal users down here. We have system user and we have the root user, which is also called admin user and could also be referred to as the super user, okay? So the root user, we already see who this person is. This person is the most privileged user in the Linux system. And this person has complete control over the entire system, right? That's the root user, that's the admin, okay? Root, admin, okay? Or super, you see? Those names tell us what the person is capable of doing, right? So there's only one root user, okay, in the system. And its username is usually root, okay? The username is root. Of that single root user is root, okay? So just to note that the username is root, okay? The username is root. Okay, so the username of the root user is root, okay? So now, if there's just one root user in the account, it means other people are considered normal users, right? Other people are considered normal users, right? Other users other than root, okay? Other users other than root, they are considered the regular users, okay? So that's the way we can look at it. We can say, oh, regular users of the system, right? Like Lagbaja that will create Tamedroom. All those people working in the organization, they are regular users, okay? They are regular users and they are created by the root user or the normal or the super user, right? So these regular users are created by the root user or the super user, okay? Now, then what then is system user? Okay, what then is system user? If every other person is normal and we have just one root user, so the system user is a user that is created by a software that is installed, right? For example, in the course of our program, we'll see that a user called Jenkins will be created when you install Jenkins, right? A user called Jenkins will be created. So Jenkins is an application which we'll learn about, is an automation tool, right? Which we'll learn about in the course of this program. So when Jenkins is installed, a user called Jenkins, right, is also installed. But that user is a system user. It's not a regular user like Lagbaja or Tamedu, right? It's just a user Jenkins, right? Created to administer the task relating to the software, right? It's created by the software program, okay? So system users are users created by the software program, okay? Program. So that's system users, okay? So those are the users created by the system, software in particular, right? So normal users are created by the one and only root user. But regular users can get elevated privileges, okay? They can get access to use the power of this guy, right? The power of this root, okay? Regular users can be given the power to perform the functions this guy performs, okay? So that is the type of users that we have in the Linux system. So the next thing we want to look at is the Linux directory structure, okay? The Linux directory / file structure, okay? So this is where we start, okay? So now, if we've been able to go this far, okay, we've done well for ourselves, because this is the foundation, right, for what's to come, okay? So, and every other thing that will come after this is simple. Always bear in mind that you don't need to memorize anything. Work with the quizzes, work with the flashcards that will be provided, and watch the videos. And if you think there's something you've heard me say that you think you need to learn more and you didn't find in any of our resources, okay, you can just make a note of it, and feel free to go on the internet, right? Go on Google, what is this? If you want to learn more about something, probably you felt, okay, the explanation is not detailed enough, or you feel you want to know more, okay? Because this is how I learn, okay? So I also want you to be able to learn that way, okay? So just scribble a note, okay? Then do your research, right? Okay, why are these? Okay, Ademola said system users are created by software program, and he said Jenkins. Okay, so how is that even possible, right? You might want to know more, right? But don't worry, all of those things we are going to do. We are going to create, install packages. You see these users being created, right? So as we proceed with the program, as we progress, right, you realize that everything that we are doing, there's a reason for it, and it's not difficult, okay? So now I want to look at the Linux directory structure, okay? So, but instead for me to start saying, okay, this is this root directory, this is that, and start explaining, why not get our hands dirty and look at each of these components of the Linux directory structure, right? So let's look at the different components of the Linux directory structure, okay? So what I want to do, let's log on to our server that we created yesterday, right? So remember, this is our email address, root user email address, and I have a password, I know it. Okay, so I proceed to coming in here. Once I'm in here, you see, right? You can see EC2, right? Recently visited, right? EC2. Okay. So I click on that. It shows me that I have one instances, right? But this instance is not running, right? Because I stopped it. So we need to learn how to use these resources, okay? So that when we'll get used to it, we don't just leave it on, right? So that when we start installing server, although now it doesn't matter, you just have one. But once you start to have two, just ensure that you are shutting them down, okay? So if I click on this, instances, you can see it is currently stopped, okay? How do you start a stopped instance, okay? First thing you do, you check this box, okay? And you come up here, you see instance state. What's the state? The current state now is that it's stopped, okay? I want it to start, okay? So you can now click on this, start instance, okay? You see, successfully started. You can see at the moment it's pending. Before you know it, it changes to running, okay? So when it starts to run, we can be sure that it has fully started, okay? So it's still pending at the moment, but nevertheless, let's see. Public IP address will only come up when it is fully started, okay? So there's something I want you to know, okay? You can see this public IP address will always change when you restart the server, okay? But the private IP address never changes, okay? Private IP address is constant, okay? And see now it's running, okay? So you can come here, copy, I've copied, okay? The IP address, okay? Because we need it. So let's go to mobile xterm. Mobile xterm. Okay, this is my mobile xterm. I want to have a wider screen. Start a new session. Remember, we did this yesterday. And the good thing is, we'll keep doing it over and over until it sticks. Because anytime we come in here together, working, I want to start my server. And you see, as we are doing it over and over, you realize that, oh, this can be very easy, okay? So you see, I entered the remote host, which is the public IP address. I specified the username. Remember, this is a Red Hat server, and you also saw how we got it yesterday. It's EC2-user. Ensure you use lowercase all through and type it correctly. Port 22, while it is open, that's the only way we can access SSH, right? Use private key, okay? And select your private key from your list. Okay, this is my private key. It's February 2023 DevOps class. Okay, so then I go ahead and click on okay. Says this, I accept, no problem. So I expand my screen. I'm pressing control down, I'm pressing plus to expand it till it gets to where I want it to be. Okay. So now I can see all sorts of things on my screen. I want my screen to be less wordy, right? I just want a blank screen. Can press enter, clear. Clear takes it all off, right? So I have a blank screen now, okay? We've not started. We're actually just trying to look around, okay? So I want to explain the directory structure. Remember, we talked about case sensitivity in Linux, and we've tried it out, okay? We've seen, tried to use the name EC2-user with uppercase E. We saw that it didn't work, right? So we mentioned that Lagbaja with uppercase L is different from Lagbaja with lowercase l, right? So that's uppercase case sensitivity, right? In Linux, okay? So also, we'll also see that with our experience with Windows and other operating systems, you say, let's open the folder, right? And come here, click on this to open a folder, right? And click on this to open a folder. You can do all sorts, right? But when you are discussing Linux, right? When you are discussing Linux, you are looking at directory, okay? You are talking about directory, right? You are not talking about folders, okay? You are using the word directory, okay? Directory, okay? Let me type that out, okay? Directory is to Linux, and folder is to Windows, right? Directory is what we use in Linux, okay? So it's just like a synonym, okay? So now, another thing we should know is that, let's see, okay? So here we are on a Linux server, okay? So the best way I feel we can explain this is to get our hands dirty and practicalize these things, okay? So in Linux, okay, hidden files, there could be hidden files, right? If I just say, remember we used ls yesterday, remember ls? I wanted to see the content of our location, right? Everything that is in our location, I wanted to see the content, right? Remember that it showed us our key, right? All the keys that we have and those other things in my download folder, right? So right now, if I press ls, you see that there's nothing here. It shows that there's nothing here, okay? But there are actually some things here that you can't see, okay? And the reason why you can't see them is because of the way they are saved, okay? To make a file hidden, you need to save it as with dot preceding it, okay? So for me, to see these hidden files, I want to use a command, okay? We'll get to learn all these things, don't worry. We've not started, okay? So now you see that I pressed ls, I didn't see anything, right? Because the files are hidden. However, when I pressed ls-a, ls, you can see, space, -a, all of a sudden, all those hidden files appeared. You can see .ssh, .bash rc, .bash underscore profile, .bash underscore logout, .bash underscore history, dot, right? You can see all of these are in there, but they are hidden because they are preceded by 0, okay? They are preceded by dot, okay? So when you name a file and you precede it with dot, it means you want it hidden, you want it safe. Why will you want to hide something? You don't want somebody to mistakenly delete it, right? So you hide it, okay? So when a file is hidden or a directory is hidden, you can be sure that it won't be easily deleted, okay? So that is one of the reasons why people will want to hide a file, okay? So now that we've seen that, I think we've looked at something very important, okay? Now, when you say dots, okay? When you say dots, it can also denote something else, right? It can also denote the current directory, okay? Okay, it can also denote the current directory, okay? For example, I can say, okay, we'll get to see that later. Let me just stop at saying it can denote the current location, okay? When you see dot, it can also denote the current location. But when dot precedes a file or a directory, the intention is to make such file or directory hidden, okay? So that's that. So now let's look at the structure itself, okay? I'm clearing this, okay? Let's look at the structure, the directory structure, okay? So if you say, right now, I'm at the home of this user, this EC2-user, right? I'm at the home of this user, okay? So this is a user. Remember, we logged in to an account, right? And we specify the user as EC2-user, right? Which is the default user for a Red Hat server, right? So that's our default user. So I'm logged in as this user. I'm not logged into root, okay? Okay, I'm not logged in as root, okay? So now that we've seen this, if I want to change directory, remember we used this yesterday as well, right? So we've not started, but we've actually started using some of these commands, but we'll still go through them, okay? But we've not started. I just wanted to see. CD, use it to change directory. We know what a directory is, right? Directory is a folder, right? In Windows, right? Want to change directory? Instead of using your mouse to navigate and do all of that, you can just use this command line, right? You can see this is a command line interface, right? You can just come here, type CD, you are given an instruction, okay? Change directory. That's CD, that's what it means. Change directory to what? To root, okay? I say change directory to root, okay? If I click on this, I'm in root, you can see. This, I'm out of this sign, I'm now here, okay? I'm inside this directory, okay? So change directory to root, okay? So if I ls-root, ls, right? I'm right here right now. You can see, I see several directories, right? We are trying to learn about these directories, okay? So the main directory is the root directory, okay? So now, forget about the user now, okay? Let's not mix it up, okay? There's a user called root, and there's also a root directory. The root directory is like the main directory where every other directories can be found, okay? The root directory, okay, is like the main directory, the parent directory, or the highest level directory in the file system hierarchy, right? So it is in here that you have every other thing, okay? For us to appreciate this, okay, let me quickly install something, an utility, a tool called tree, okay? I want us to see how all these look like in a tree format, okay? I want us to see what everything looks like in a tree format, okay? So let me just install tree, okay? Don't worry, we'll still go through all of this, okay? This is just by the way. We are trying to understand the directory structure, but anyway, let's not install tree. Let's not make anything look difficult, okay? So now we've seen that this root is like the parent of all directories. You can see there's AFS, there's bin, there's boot, there's dev, there's EFI, there's etc, there's there's lib, there's lib64, there's media, there's MNT, there's OPT, there's proc, there's root, there's run, there's sbin, there's SRV, there's SYS, there's TMP, there's USR, there's var, okay? So I do not expect us to know all of this right now from the get-go, okay? But we'll take a look at the important directories that are commonly used, okay? We'll look at the important directories that are commonly used and what they are used for, okay? So let's start with okay? See, this is okay? This okay? So if we cd to or alternatively, if we say ls and we see what is inside okay? ls and see what is inside you see, contains all the users in the account, okay? Contains all the users in the account. You see, we've looked at roots, and under roots, you find right? And under you find user. So if we create another user, maybe Lagbaja or Tamedu, we realize that we won't just see user here, okay? We won't just see EC2-user here. Rather, we will also see Lagbaja and Tamedu under this place, okay? So directory contains all sub directories for each user, okay? For each user, okay, you find their directories there, okay? Each user will have a directory, okay? So you have EC2-user, you will have Lagbaja as time goes on. Don't worry, we'll still look at this as we proceed, okay? So that's okay? It contains all users, okay? Is where you find all the users. So let's look at another popular one, okay, which is important. See, we've been running commands, right? We've been running ls, we've been running cd, we've been running this, we've been running that, okay? All those commands are regarded to as binary executables, okay? They are binary executables, or we can just say they are binaries, right? So those commands, they are somewhere in this folder, in one of these folders, okay? And remember I said binary executables or binaries. Binaries. Where can it be? What do you think? Where can it be? So it should be in this bin, okay? This bin is like an abbreviation for binary, okay? So inside the bin directory, you find all the commands, right? Remember we've run some commands, few commands. We've run cd, we've run ls, right? We've run cd, we've run clear, right? If you remember, at least we've run 3 commands: cd, ls, clear, right? So if I do ls, right, and I put root, because I'm in root, I'm right here in root, I can choose not to put this root sign because I'm right in root, right? But otherwise I would have put root sign, okay? I'm right here. I'm not using this time, but rather I want to check inside bin. I want to make a list of everything inside bin, okay? So if I do this, see, I have a lot, right? You can see the lot that I have here. I have so many stuff here, okay? But let's see what will be familiar, right? Remember, we ran a command. We ran some commands, right? I remember we ran cd, right? You can see cd, you can see all the commands we are running, okay? They are here. They are in the binary directory. All the commands we are running, they are in the binary directory. So all of these commands, I'll tell you, not all of them you need to know, right? You just need to know a few. And if you need to do something, you can learn more commands that will relate to what you are doing, okay? You just need to know the key ones, right? Since yesterday, you see, there are some commands that kept coming, right? The clear command, the cd command, the ls command, right? There are some of these commands that even I myself have never used before, right? So many of them, not just some. So many of these commands, even I myself have not used them, right? Because the use case warranting them has not risen, right? So once the use case comes and I need to use them, all I need to do is to go learn what the command for that will be. Because I know what I want to achieve, I'll just search. What command do I need to do this, right? Then I'll search, I'll learn, I'll know. Okay? Because it's not possible for any individual. There's nobody that can boast of knowing all the commands, right? Because there are just so many, right? You just know the few you can know and use it for your purpose. Some commands, you even end up not using it in a lifetime, right? Okay, so there are just several commands, okay? So if you remember, we use cd command, you see, it's here. So all the commands are in the binary directory. You see, we use clear, right, to clear our screen. You can see it here, clear, okay? Which other command did we use? We used ls to make a list. See, you can see ls, right? ls, okay? You can see, so you can see ls attributes. This one will list attributes, right? ls blk, this one will list block. ls CPU, this one will list CPU, okay? So there are several. So once you know one, right, even if you've not used some of these commands before, but once you see them, you have an idea of what it's all about. Oh, ls attributes, right? You have an idea, you just have an idea because you've used one, right? Right? You get to see, oh, you see, right? You see, these are different commands. And where do you find them? You find them in the bin directory, okay? So we've looked at two directories, right? We've looked at actually three, okay? We've looked at three directories. We've looked at root directory, okay? We've looked at /home directory. We've looked at /bin directory. You can see it's making sense, right? So all the commands we are running on the Linux server, they are in the bin directory. Okay, you can see all the commands, right? You can see all of them. There are not even so many, right? You can see all the commands that are in the bin directory. Okay, so those are all the commands that we have in the bin directory. So if I mistakenly delete clear, right? Because I've actually done that before, you know, if I deleted clear and I just realized that I couldn't use the clear command again because it is no longer here, right? So it is no longer here, right? So when you delete a command from the bin directory, it will no longer work. That's as simple as it is, okay? So what is making it work is because of its presence inside the bin directory, okay? So we've looked at bin directory, that's fine. So let's make good progress, okay? The next thing I want to look at is, let's look at sbin directory. Let's take a look at our ls. Let's see the ls, okay? Let's see what we have here, okay? So we've seen bin, okay? We've seen bin, system binary is sbin, okay? This one is bin, okay? But this one here is sbin, okay? Let's take a look at what we have in sbin, ls dash sbin, right? Okay, system binaries, okay? So these are also commands, right? These are also commands. But these commands, okay, these commands are commands that can only be executed by the root user, okay? You know, we said there's just one root user, okay? But these other commands here, everybody can execute them, whether root or non-root, right? Or regular user, you can execute these ones at the top, right? Like the clear command, this command, that command, clear, ls, you know, cd, all those commands. Anybody can execute, whether you are root or normal, right? But these ones here that we have under systems binary, they are only executable by the root user, right? So those guys with root privileges are the only ones that can execute this, okay? So, for example, let's see, I'll show you something and you even without knowing this before, you tell me what it's for, okay? I want to look for something and show you so that you tell me what it is for, okay? What do you think this is for? This command, user had, okay? User had. So although we've not done this before, but from the way the name is, we can tell it is for adding user, okay? So it is only a root user that can add user. You can see user del is another command to delete user, okay? So you can see you can only find this in the SBin, right? So what it means is that if a non-root user wants to use these commands, it is actually possible. But the normal user must have been given elevated privilege, admin privilege, to be able to run it, okay? And once the admin user, the normal user is given an admin privilege, it means the person is able to run this, but cannot just run it by running the command. The person needs to use sudo, right? Before it, like putting sudo before putting this command, okay? Before, that's the only way the command can get run, okay? Okay, so now that is system binary, okay? It's good that we've seen the different users. We've seen normal users, we've seen systems user, we've also seen root users, okay? So the root users alone have the right to run the binaries in the SBin, right? Whereas everybody can run the binaries in the bin, okay? We've looked at bin, we've looked at SBin, we've looked at home, okay? So we've seen users and we've seen what they can do, okay? So let's just put this here, SBin, okay? /SBin. That's system binary, okay? So now that we've done this, so the next thing we want to do is to look at something else, okay? Is to look at something else. So let's look at the /etc directory. Let's look at the /etc directory, okay? So let's clear this. Let's clear this. Let's have a clean screen. You can see we use the clear command, right? Okay, so you can see because it's in the bin directory, we are able to run it just as it is without putting sudo, okay? So the next one I want to look at is the SBin directory. So let's see what is in the SBin directory. We've looked at SBin, let's look at etc, I mean. Okay, so let's even ls here and see everything we have here, you can see. So where's etc? So this etc, okay? So the etc directory is a directory that contains configuration files. ls, right? I want to list what you have in etc. That's what this means. ls, what you have inside etc, okay? So that's what that command does. It's still ls command, but we are listing what is inside etc. etc is a directory here, you can see. Okay, so you can see these are all configuration files, okay? These are different configuration files. You can see pass wd, sudo.conf, sudoas.d. You see, these are different configuration files, right? So the etc directory contains different configuration files of the system, okay? So you can see this is a configuration file, for example. If we open it, okay, we can use cat command, cat, okay, to open this configuration file, okay? But let me put just cat, should work, but I'll not be able to do anything else. If it doesn't work, I'll use sudo, okay? So if I put this, okay, it says no such file or directory, okay, because I am inside. Okay, I get. Okay, so what we'll do, because there's something called absolute path and relative path. Okay, there's something called absolute path and relative path. Okay, so remember here, I was able to say just ls, right? And specified etc because I'm right here. Okay, but if I try to do the same, right? I want to access something that is inside etc. I can't just say cat passwd. I need to go inside etc before I can run this command. Okay. So remember the command we ran. Okay. Let's go back. I'll clear it. So for us to be able to run that command, it's either we say cat slash etc. Okay. Slash etc slash passwd. Okay. So when you look at this, you can see it's like a long path. It's like specifying, okay, if you enter this room, you find this. Then inside this room, if you enter that house, you find a room. Then inside the room, you find a cabinet. Then inside the cabinet, you find this, okay? So if you have a path specifying that long stretch, oh, home slash room A slash cabinet, that is absolute path. Right? Whereas if I'm right inside that room, I can dip my hand in the cabinet and pick out what I want to pick, right? But if I'm outside and I just say cabinet, somebody's like asking, which of the cabinets? The one in which room, okay? So that is exactly what this is all about, okay? We call something absolute parts and we call something else relative parts, okay? If you are right here outside, right, and you need something from the cabinet in a certain room, you need to say, okay, I want something in that cabinet that is in room one, that is in this house, right? That is what we've done here. We've specified like a part, like an absolute part, okay? Whereas if we were right, like here now, you see, if you look at this, if we are right here in this room and want to pick something from the cabinet, we can call that relative part, okay? But if it's far away, we use an absolute part. But if it's close by, you can use a relative part because it's right beside you. You can just, there's this close relationship. You can relatively just dip your hand in the cabinet, right? And get what you want. But if you're outside, you're not plastic man, or what do they call it, that can just stretch, right? You need to specify, okay, can you help me get this? I can't go there directly. It's in this house, in room A, and in that cabinet close to the wall. Open the top drawer, right? And you pick it, right? So that's why we need to use absolute part, right? So we'll learn about absolute part and relative part as we continue in the program. So this cat command, what it does is that it displays the content of a file, right? Call it concatenate, okay? It's on concatenate. It displays the content of a file, right? So let's see. You can see this is the content of the file. you can see, it's displaying information about the different users, right? It's talking about root. If we scroll down, you see something like EC2-user that was created, right? So all these ones you see here, they are information about users, right? This EC2-user, you can see, is defining it as a cloud user because it was created by AWS, right? And this is the home, right? So this is an example, right? You can see this a configuration file really talking about different users, right? So this is fine. So let's clear, okay? So we've also looked at a file, a directory called etc/etc directory, right? So the /etc directory contains the configuration files, okay? /etc contains the configuration file. You can see we are moving, okay? Contains the configuration file. You don't need to memorize any of these things, okay? Go through the videos, get hands-on, right? Like trying to do all these things we are doing, okay? And once you are able to get your hands on them, you realize that they are not difficult. There are flashcards will be provided for all of this. There will also be quizzes where you use to test your knowledge. And those quizzes are so powerful that once you try it the first time, you try it the second time, you just realize that you've perfected your art, okay? So that's the /etc directory, okay? So let's pick another directory, okay? Let's pick another directory. Let's see what we have here. Let's see. Remember, we used the pwd command yesterday, print working directory. You see, we are in root. Okay, you can see we are in slash. Okay, so if you come here, you can say ls. Okay, so let's look at another one, popular one, this opt directory. Okay, so this opt directory, if you look at it by default, there's nothing in it. You can see there's nothing inside. Okay, so the opt directory is an optional directory. You see, opt, optional, right? Opt directory is an optional directory. Okay, so it can be used to install third-party software. Okay, for example, we've installed this server, and we'll be working with DevOps tools as time goes on, and we'll be installing several tools and all of that. So those tools are softwares. They are third-party softwares, right? That we need to get our work done. So usually /opt directory is a place where you want to store those third-party software. Okay, so that's /opt directory. Okay, by default it comes empty, right? So, and you see we are looking at all these things and we are able to see how they are, right? So if at an interview they ask you which files do you find in the /opt directory by default, right? Like it comes empty, right? But you can use it to store third-party software, third-party applications, right? So now that's that, okay? So let's take a look at something else, right? You can see it's getting easy, right? Home of users, right? Users, right? Their home, bin, binary, right? All the commands are found there, which not every user can use. SBIN, system binary, only commands that root users can use, okay? etc, configuration files can be found here, okay? opt, optional, right? Only third-party apps are installed. It comes empty by default, okay? So let's look at something else. Let's take a look at here, ls. Okay, so let's look at this proc, okay? Proc directory, proc, okay? So this way, we can know what each is proc, okay? So if we go ahead and check ls proc, okay? Let's see what is inside proc. You can see. So when you look at this, what you find there are the processes, okay? When you run something on the Linux server, okay, when you run something, they run as processes, okay? They run as processes. So information about the processes, you find them here, right? Proc, processes, okay? Proc directory, processes, okay? So all of these things or this this presentation that I'm using is just for us to be able to remember, right? Process ID, proc, okay? So if you're at an interview, they say, oh, what do you find in proc directory? Okay, oh, that's process. So process IDs, right? About processes running on the Linux server, right? You can see different process IDs that we have here, okay? So that's proc directory for you, okay? So the proc directory will contain processes, details on processes, right? Processes, information on processes, right? That's what you find in the proc directory, okay? So another directory we can look at is, let's look at lib directory, okay? Lib, okay? Lib directory. Library, okay? So the lib directory, let's ls lib, okay? The lib directory, you can see, it contains the lib directory contains the library files that are used by the operating system, okay? So these are the library files used by the operating system, okay? Used by Linux, okay? So these are library files that are used by Linux, okay? So this is where you find them, okay? Lib. So as we proceed in the program, you get to understand all of this better, okay? So now we are just trying to understand the entire directory structure, trying to like look at, oh, what is this? Why are we looking at it? You know, instead of just picking the directory and trying to explain, oh, this is this, that is that. But this way, we are able to see what is inside and understand it so that it can stick, right? So this is the lib directory, okay? So the next thing we can look at is, let's take a look, another popular one, okay, var directory. From var, what do you think? Sounds like variable. Okay, exactly. That's what it is. Okay, ls var. Okay, so the var directory contains variable information, right? Such as log files. You find log files here. You see, find log files. You know, so variable information is what you find in the var directory. Okay, so variable information. Okay, so you can see variable var. Okay, okay. So the next one we want to look at is, let's take a look at the which one, which one, which one, which one, which one. Let's look at this temp directory. Okay, temp directory tmp. Okay, if you ls tmp, okay, you can see this is a temp directory. So the temp directory contains temporary is for temporary storage, TMP, right? Temporary. Temporary directory is for temporary storage. And the good thing about this storage is that if user A wants to share something with user B, right, can just dump it in the temp directory for the other user to access. Okay, so there are different users on the server, and you want this user to get certain information. So all you need to do is to put it in the TMP directory. We'll see how to put things in different places and how to create all of these directories and files. They are not difficult, I must tell you. They are not difficult, okay? So another thing we can look at here is, let's take a look at dev, okay? Dev directory, dev from device, okay? Dev directory contains information about external devices connected to the system, okay? So that's dev for you, okay? ls dev, okay? Let's see, this contains information about external devices connected, okay? So that's dev device, okay? So now that we've looked at all of this, okay, I think this is a good time for us to, we've looked at all the important directories, okay? This is a good time to start looking at Linux commands, okay? Linux commands. Let's see, let's clear this, okay? And if you remember, our commands can be found in the bin directory and the sbin directory. The bin directory is for all users, whereas the sbin directory is for the root users, right? The root user. Okay. So let's look at Linux commands. Okay. Let's look at Linux commands. Okay. Some of the Linux commands we want to look at. Let's cd. Remember? Cd. Okay. When I press cd, it takes me home. Okay. But let's start. Okay. Now we've seen directories, right? We've seen directories. We know what directories are, right? We've seen different directories in the directory structure, right? So now let's look at some commands that we can use to navigate around directories and do some interesting things, okay? So let's start with PWD, which we've seen before. PWD means print working directory, okay? It tells us where we are, the directory we are in now, right now, right? So, and the directory is /home/ec2-user, right? So we are looking at within root, there's home directory, and within home directory, there's ec2-user. Remember how we were able to navigate to that place the other time, right? So this is the home of ec2-user, right? So that is the present working directory, okay? So PWD means print working directory, okay? It tells us the present working directory, okay? So now that we are here, when we did ls, remember, to list, we saw nothing, whereas there are some things actually, okay? But let's say you want to create a directory, okay? Let's say you want to create a directory and call the directory maybe February class, right? February class, okay? So to make a directory, okay, we are trying to create a directory. Let's see, make directory. That's what you want to, that's the action we want to take, right? So there's a command called mkdir. I'm sure you know what this command does. Is to make directory, right? So this command is able to make directory. mk make dir directory, okay? So it's all about abbreviation. It's not something you are supposed to just know by knowing, right? It's something you know by seeing once and using almost always, right? You don't expect me to just, without knowing this before, without coming across it, you don't expect me to assume it, that, oh, this is it, right? Okay? So, and I'll also tell you, there are several commands that I've never even used, and there are several that I will not, now I will never even use, okay? So, but these ones are commonly used commands, okay? mkdir, make directory. So if I just say make directory, doesn't make sense. What directory? Do you want to have a name for the directory? Yes, I need to specify a name for the directory. So when you use mkdir, you need to specify the name you want to give the directory you are making, right? So let's say I want to call it February class, okay? I can say February class. Okay. So there's something I want you to notice. I typed February class together, right? What will happen if I decide to space it and say February, Feb class? What will happen is that two directories will be created, Feb and class, okay? But I just want one directory called February class, okay? So I can either do this, say Feb class together, or use underscore, or whatever it is I can use to combine them together. But typing it as Feb class, I think makes sense because anyone that sees it will know it's February class, okay? But if I had written Feb class, it will still work, right? But someone would think, okay, this is a word, Feb class. What's Feb class, right? It's ambiguous, right? So Feb class shows me it's February class. I can make a directory, call it February class, right? Okay. So now that I've made a directory, remember when we did ls earlier, we didn't see anything, okay? So right now, if I do ls, you can see ls, something we use almost always, right? So definitely it will stick, okay? Running ls again to see. So if I run ls again, it will show me that there's a directory called Feb class, okay? Because we made it, right? So we made this directory called Feb class, okay? We made this directory called Feb class, okay? So if for some reason I want to exit this user, right? I'm logged in as EC2-user, right? I'm done. I want to exit this user. I run this, exit, right? It has logged me out, okay? So, because I use the exit command, right? I use the exit command. So it has logged me out, okay? So if I want to log back in, okay, I have to go to sessions, okay, and start all over, right? You can see. I can't remember my IP address. Let me go copy it. Okay, so I copied this again. That's my IP address. Come here. Specify username, remember, EC2-user, right? You see, make sure you type it correctly. And I select my key. Let's use a key to get in, okay? So February 2023 DevOps class. Okay, so click on this, right? I'm back in, okay? So I'm back in. So I use my clear command. I have a clear screen, okay? So we've been able to look at the ls command. We've been able to use the pwd command, and we've been able to create a directory called mkdir. We've also gone ahead to delete to exit, right? To log out, okay? To log out, we went ahead and clicked on, typed exit, okay? To log out of that user, okay? So what we can do is, let's take a look at something else, okay? So now that we've created a directory, okay, we can go ahead and look at, okay, let's see what the directory structure. It will make sense now, okay? There's a command called tree, okay? The tree command will show you what the directory looks like, okay? We are in the home of EC2-user, right? So if I run tree command now, I'll get an error because tree doesn't come installed with this Linux server by default, okay? So we need to install tree, okay? You can see it says command not found, okay? So because of that, I need to install tree. So let me install tree so we can appreciate the directory structure, okay? Sudo yum, okay? Because I want to use yum install. That's why I'm using sudo. Remember we talked about sudo, okay? Sudo privilege. Because EC2-user has the privilege, right, to do some things, right? install tree. Okay, so this command is sudo yum install tree. We'll still get into all of this. Okay, this is not something we are looking at, but I just don't want to just type things without explaining what it is. Okay, so this command will, this sudo part is giving this guy an elevated privilege to do something powerful. Okay, yum is a package manager for Red Hat. Okay, install is a command, right, which is obvious. Install, we want to install. What do we want to install? We want to install an utility called tree. And I don't want the system asking me questions while installing. Okay, that's why I'm putting this -y. If I take it out, at a point, it will ask me, do I want to continue? And I'll say yes. Let's just do that. Okay, so you can see I'm installing tree. It's asking, install size is this. Is it okay? I'll say why, right? Then it's installing. It's installed. Okay. So remember the other time we ran tree command and it says command not found. Okay. So right now that we've installed, that's clear. Now that we've installed, if I go ahead and run tree, what do you see? It shows us that there's something called February class. Okay. Now remember, we said there are some files that are hidden that we can't see, right? Because they are preceded with dots. Okay. So for us to be able to see those files the other time, what we did was that we put -a in front of the command we ran, okay? ls-a. So can we use -a here too for it to appear? So this tree command, let's see, -a, right? You can see, we see the directory structure such that even things that were not visible before have now become visible, okay? So here you see that this is a directory, but it's an empty directory, right? Whereas this is another directory, but it contains something, authorized keys, okay? So you can see it's giving us this result in three formats, right? You can see showing us what you have inside this, it will get complicated by the time we start creating directories and subdirectories, okay? So we'll appreciate this tree command better then, okay? So now we've seen that we are able to create a directory, but this directory is currently empty at the moment, okay? So that's the directory we've created, okay? So the next thing we want to do, okay, we've seen how to use the ls command, right? ls command, we've used it, we've used ls-a, right? Okay, we've used ls-a. So there are several ways we can use the ls command, right? But bear in mind, ls means list, right? List, okay? So use ls to list, and we've seen how we've used it a lot, right? But you can also use ls and use it with some other components, okay? So for example, remember, if I say ls-a is a way of using this, right? It shows everything that we have here, okay? Even hidden files, right? But if I go ahead and say ls-a, okay, l, okay, ls-al, okay, ls-al. This has listed everything that we have here, but it has listed them in a different way, okay? It has listed them in a different way. It has listed them like in an alphabetical fashion, right? You can see it's listed everything, okay? You can see we have, what date do we have here? February 29th, August, you see? You see? So it's not by dates, right? ls-al. So the reason why I'm using al here Okay, I could as well say ls dash dash L, okay? But if I just use L, right, it won't show the hidden files and we can't appreciate it so much, right? Because we've only created a directory, okay? Look at it. You can see the dilemma we have, okay? So before we now proceed to using all of this ls dash L, ls dash L, and other options, right? Let's see whether it is possible to create a directory with subdirectories, okay? Which is something that is possible, okay? Remember, when we created a directory, right, we use mkdir to create a directory, okay? We use mkdir to create a directory. And directory we created was feb class, okay? It is possible for us to create a parent directory that we have other subdirectories. Okay, for example, we can create a directory and call this directory 1, right? And we'll create another directory 2 inside directory 1, right? And we can create directory 3 inside directory 2 and create directory 4 inside directory 3, okay? So here you are looking at a structure such that you have a parent, a child, a grandchild, and a great-grandchild directory, right? So if we just run this as it is, we are going to encounter issues because you can't run this like this, okay? It says mkdir cannot create a directory like this, okay? But for us to be able to make it happen, we need to let pass a flag and say, okay, we are trying to create a parent-child arrangement, okay? By putting dash P here, we tell the system that, oh, okay, so you want this to be in parent-child format, right? Such that dir1 will be created and dir2 will be created inside dir1 and dir3 will be created inside dir2 and dir4 will be created and that way, okay? So if I run this now, you can see I don't get an error, okay? But it's actually done. But how do we see whether it's done? I can do ls. If I do ls alone, I only see dir1, okay? Because you are looking at, remember we talked about absolute part and relative part the other time. Right here, we are in home of EC2-user, right? And right here, the only thing I can readily touch from outside the house is the wall or the door to the main house, right? I can access the main house, right? So that is what I can do, okay? So also with this, right? I'm only able to see dir1 that was created. But dir2 was created inside dir1 and dir3 was created inside there. But how do I see all of this, right? Because they are not here. I can't see them, right? So it's difficult, okay? So to be able to see them, you used to use the tree command, okay? So you see, with the tree command, I'm able to see, okay, this and this are contemporaries. You can see they are in the same class. They are in the same level, okay? But this one has something inside here, this one has something inside here, and this one has this inside here, right? So this is a subdirectory of dir1, and dir3 is a subdirectory of dir2, and we have dir4 being subdirectory of dir3, okay? So this is the beauty of the tree command. It's able to show us all the things we have in tree command, okay? So I didn't have to use ls-tr3-a to show the tree again because I can see something I can use for an example, right? So we want to make our tree more beautiful, okay? So we can still go further and do something interesting, okay? So what we can do is to go inside dir1, for example, cd, right? We are in the home, right? You can see this sign shows us that we are in the home of EC2-user, okay? This sign indicates home of any user that you are in, okay? So if I go into dir1, okay? Oh, dir1, number lock, okay? So I'm in dir1 right now, okay? So if I do my tree command, you see that I only see things inside dir1, okay? Now, let's say inside dir1, I want to create another directory that will be a contemporary of dir2, okay? I can call this directory, let's make it mkdir, remember, -p, right? Because I want to create a parent-child relationship within here as well. Let's say I want to call this one dir a, directory A, and inside directory A, I want to have directory B, and inside directory B, I want to have directory C, okay? So you can see, I want to have this complex situation. But if you remember, when we created directories here, we didn't get any sign that anything was created. There's no notification. We just, what's happening? But we created directory SHA. That's all we knew, right? And we knew that it was successful because we knew what we were doing, right? Okay. So now, if I want this thing to display, okay, what is being created, okay, all I need to do is to introduce V, okay. I want to be able to visualize what is being created, okay. I want to be able to visualize it. What we are creating, I want to visualize it. So I use the -pv flag, okay. So if I run this, you see, it tells us mkdir created the directory A, then it created directory B, right? This means it created B inside A. Then it created directory C inside directory B that is inside directory A. Then it created directory D inside directory C that is inside directory B that is inside directory A, right? So I'm not a good rapper, right? But we can see the process. We can see what it's doing. It's doing this step by step. But when we run it as this without putting the V, we don't see what happened at the background, but we can appreciate it more now because it's steps, right? Because of this flag, this is extra instruction, the shell understands what is required, right? Create this, then create this, then create this. It's creating it one at a time, right? Okay. It's not just creating everything at a time, right? It's a process, okay? So it's creating everything one at a time. So now that we have this, let's look at our situation, right? Run 3 now, you see, we have this and this and this. But wait a minute. I want to see everything that we had before, right? I want to go back home to the home, okay, of the previous user. So to do that, if you want to go a step to the parent directory, you want to move a step up, okay, you run cd ... okay, we are moving a step up. Remember, we've used cd command, okay, but we are coming from a place, we came inside, we are coming from home where we could see directory 1, but right now we don't see directory 1 again. But want to go to a step, we want to move to a parent directory, okay? You use cd ... okay? So now that we've done this, we've gone back to home. You can see here we're in directory A, but now we are back at home, okay? So if we run the tree command right here, you see, we see directory 1, we see feb class, and inside directory 1, there's directory 2, and there's directory A, right? Then inside directory 2, there's 3, and inside directory 3, there's 4. But here, inside B, you have A. Inside A, you have B. Inside B, you have C. Inside C, you have D. You can see the tree is able to show us our directory structure in tree format. Okay. So the reason why I didn't install this tree earlier was that if I use the tree for the roots, it's going to show so many things and it will even get us confused. Okay. But now we are able to see what is inside what and why is inside why, right? Because we created them. Okay. So now remember we use this to move a step upwards, right? To move to the parents. Okay. But remember, where are we coming from? We are coming from inside here, directory 1. Okay. So there's another command that can take you to, there's a command that can take you to where you were coming from. Not necessarily a step upwards or a parent, right? But wherever it is you are coming from, there's a command that takes you there. Okay. For example, if you do cd dash, this cd dash takes you to where you are coming from, no matter how far away it is. Okay. So you see, but where I'm coming from is directory 1, right? So it takes me back there and it displays it. You can see this is the absolute part of directory 1, right? cd dash, okay? But I can decide to move to what directory, okay? Let me even travel far away, right? I can go to cd, okay? Let's say cd slash opt, right? Remember, opt, that empty directory is far away, right? opt, if I move a step upwards, right? If I do cd dot dot, I go to root directory. Remember where we've been before? We've done this before, okay? Takes me to root, but root is still far away, right? And if I do cd dash, it takes me back to opt, but I want to go to user home directory without specifying the long path, okay? I could just say cd. When you say cd, it takes you to the home of this user. Just cd alone, without anything else, okay? cd takes you to the home of that user. If you do pwd now, you see, you're in the home of EC2 user, right? You're in the home of EC2 user. Let's say we mistakenly go back to cd slash root again. Let's go to cd slash root. So the same way we use cd to come here, there are also other commands you can also use to go there, okay? You can use cd, okay? You can use cd and use this sign, right? Is at the top. Beside 1, you use shift to get there, okay? Side 1, before 1 on your keyboard, okay? If you do cd home, it means you want it to take you home, okay? So if you check pwd, where are you? You're at home, the same home. You can see cd alone takes you home, but why stress myself putting all this when cd alone will take me home, okay? But it's just good we know, okay? But usually I just use cd, it takes me home anywhere I am. cd takes me home. cd takes me home. Okay, so the next thing we want to do is, other than this, we can also, let's go to opt again and look at other options. cd slash opt, let's say cd slash opt, and I want to go home again. You can also say cd slash home slash ec2 dash user, right? This will also take you home, okay? But this is a long one, right? pwd, you are also at home, right? So these are different ways you can go home, okay? So I believe if you try this, let's see, cd slash opt. If you do this, cd, this will work in script, should work here too. User, okay, it doesn't take you home, okay? So that's fine. So you can see we've tested the different ways we can use cd, okay? cd to take us home, okay? Just cd alone takes you home, okay? So if you clear this, okay? See, we have a clear screen again, okay? We've looked at CD, we've looked at mkdir, we've looked at ls, okay? So now that we have two files, let's try to create something else. Let's create one more directory, okay? Let's call this directory X, okay? mkdir, and call this directory X, okay? Let's call this directory X. So making this directory, if you look at this, you say tree, it shows you this is what you have. You have directory 1, you have directory X, you have directory B. Directory 1 is so blessed, you can see 2 children, 2 grandchildren, 2 great-grandchildren, and 1 great-great-great-grandchild. Okay, so you can see the tree structure is able to show us the directory structure, right? So if we go ahead now and try our ls command, okay? Try our ls command. You see, we have justice here, right? So if we now do ls -l, right? You can see the way it's listed, right? ls-l, ls alone, we just list them like this. But ls-l, we list them with more information, right? But rather in alphabetical order. dir1, dirx, then feb class, right? You can see these are arranged alphabetically, not based on the time that they were created, okay? So if we want to get this list based on the time that they were created, you use ls-lt, okay? This ls-l, okay? This ls-l can also be written as ls-ll, okay? ls-ll, right? That's ls long list of -ll, sorry. Oh, sorry. ls, just ll, long list, okay? ls-l or ll, right? You see, if you run this, it's like saying long list, like abbreviating this, right? Taking this and S and L out, okay, to achieve a long list, okay? So you have ls-l, you want to make a long list, right? So, but if for some reason you want to have this arranged based on the time, right? You want to see the time based on the time they were created. Remember, we created this first, then we created this before creating this, right? So based on the time, okay, you see, based on the time they were created, this was created first, followed by this, just as we said, and followed by this, okay? But the problem with this arrangement, it looks okay right now, okay? It looks okay because we have just 3 directories. But what happens when you have like 50 directories, okay? What it means is that the list will be so long that, let's say you have 50 directories, the list will be so long, you see, we have just 3 here, say another, let's say another 5, let's say another 6, okay? By the time you had all these lines, it means you need to be scrolling up to get access to the most recent, right? You can see, this is not the most recent coming at the bottom. It will be difficult for you to access, right? I want to see the most recent, right? So you've actually, with this, you have a long list, okay? LL also shows you the long list because it's a short form of long list, okay? Long listing. Long listing based on time, right? So quite all right, this was created, the one that was created last, come here at the top, the one that was created next, in that order. But where you need to access and you have a very long list, okay? So it becomes a problem. So to resolve that, what do? We use another command, okay? We just add R, okay? So you see, we started with ls-l, then we added ls-lt, and to further solve the challenges, we use ls-ltr, okay? You can see the most recent one is coming at the bottom. So what it means is that even if you have 1,000 directories, the most recent one is definitely what you want to see, right? Like sorting based on the time, right? Earliest one coming at the bottom, right? So the most recent one coming at the bottom, right? So that is what ls-ltr does for you, okay? It reverses. You see, the first one gives you the long list. Second one gives you the long list based on time. And the third one gives you the long list based on time in a reversing order, okay? So you can see ls-ltr, okay? So we've looked at this, okay? We've looked at this, okay? So there are also some other ways we can use mkdir, okay? We can use mkdir in other ways, okay? We can use mkdir in other ways, okay? So we've also seen that we can use ls-a to display hidden files, okay? So we can also do ls-al, right? To give us long list. We can also do ls-alt based on time. I also do ls-altr, okay, based on reversed, okay, based on reverse timing, right? So let's see what happens if we choose to put our A here at the back, okay? See, it still works, okay? So you can move your A to the back and you can let it proceed, okay? You can move your A to the back and you can make it proceed, you can see. The A will make the hidden files visible, okay? So that is that on how we can use the ls commands, okay? So also, we can also use ls-i, let's see, ls-i, that will list the inode. So these are options, right? ls-i will list the inodes, okay? You can see, listing the inodes of the directory structure. So this is the inode of this, okay? We'll get to see this and understand it as we proceed with the program. You can see. So everything is all about ls right now, right? We've seen ls and different ways we can use ls, right? But as we keep using them, we'll get used to them and we'll master the art, okay? So another thing we'll need to look at is we'll take care of some other things later, but right now, let's take a look at, remember when okay, we've not done that in this class, okay. So if we want to switch user, right? Remember we have just one user here, okay? And we have another user, the root user, right? We have the root user, okay? So we have the root user. So to switch users, okay, from EC2-user to root, okay, we can use SU, okay, SU switch user, SU switch user, okay, specify dash, okay, then you specify the username, okay. We've not created any user in this class, okay, but we can create users, but I want us to take it one step at a time. But if you remember, they said there's one user in this account called root. Root is the name of the user, right? Okay, so we can actually switch to root, yeah. So, but for us to be able to switch to root, we must be very powerful, okay? Only people with elevated privilege can do it, okay? And EC2, fortunately, has elevated privileges, okay? So sudo need to be introduced, okay? So this sudo is not the command itself. Switch user is the command, dash root, okay? So sudo is just because of the privilege, right? Okay, you can see switch to root. You can see it's no longer ec2-user, right? But now it is root, okay? Because he has switched to root, okay? And if you look at it, this user, when you see this hash, shows that it's root user. When you see this dollar sign, shows that is normal user, okay? When you see the dollar sign in front, you can see it's running as normal user, okay? It's running as root user, okay? So I can say I want to exit. Remember the other time when we exited, we just exited and logged out, okay? But if I choose to exit now, where do you think I'll be exiting to? I should be exiting to ec2-user, okay? Because that is where I was, okay? But without logging into root, if I decide to exit now, it means, oh, I've closed for the day. I'm going home, right? So I've closed for the day. So on that note, I want to exit, right? So, but right now, I'm not exiting, okay? So this is how you switch from user to user, okay? So, but this sudo here is just because of the power, the elevated privilege, okay? That is given to EC2 to do it, okay? So if EC2 tries to do this without that privilege, let's see what happens, okay? See, permission denied is asking for password. I don't have a password. I don't have a password for this guy, okay? So you can see, because he's not, he has root privilege, but he's not using sudo, so it's prompting for password, okay? So if it's a user, just a regular user, maybe Ademola or Lagbaja, that has not been given the sudo privilege, okay? You see the permission denied error, okay? So I want to cancel this process. I can just press Control C, okay? It takes me out. Control C takes me out. So we've been able to create a directory. We've also been able to switch across, okay? So what we want to do, we've also seen how we can use the cd command, right? We've seen how we can use the cd command, okay? So what I want us to do today is to look at how we can remove directory, okay? Remember, when we wanted to make a directory, we use mkdir command to make a directory, right? Make a directory, we use mkdir. So to remove a directory, what do you think it's going to be? I think it's going to be rmdir, remove directory. Okay, and this is very simple, right? We just use idea and we are getting it, okay? But the good thing is, despite the fact that we can use idea to get it, there are documentations for all these things. We just need to be able to know what we are capable of doing, okay? Once we know what we are capable of doing, we just do it, right? So that is it. So that is rmdir. Let's say we want to remove a directory. Which directory should we remove? Let's remove directory X, right? So I want to remove directory X. If I remove directory X, okay. See, I remove directory X. If I do ls, I see directory X is gone. Okay, yes. Now I have the power to remove directories, right? Once I have the power to remove directories, I can remove directory 1, right? Let's see. Remember directory 1, there's something about directory 1. Let's use the tree command. There's something about directory 1, okay? There's something about directory 1, okay? Something about directory 1. Directory 1 has children and grandchildren and great-grandchildren and great-great-grandchild, right? So if I try to use the rmdir command, this one, to remove directory 1, I'm going to get an error because directory 1 has subdirectories. That is why I'm not going to be able to use rmdir to remove it, okay? Because it has subdirectories, okay? So if I use this, you see, say rmdir failed to remove directory because directory is not empty, okay? So what I can do right now is that I can take a look at other commands that I can use, okay? There's a command called rm command, just rm, okay? How can it be simpler to remove a directory when that is empty than this one that is not empty? Okay, so let's see. If I use just rm, okay, you typically use rm to delete files, okay? Maybe you have a file, there's a difference between directory and file. Maybe a notepad that you've saved, right? Remember we talked about VI. Maybe you have a file that you've saved, Excel sheet or whatever it is, or an XML file, whatever it is, right? You can use rm to remove it, right? But if it's the directory, you cannot just use rm alone, okay? If you use rm alone, you are going to get an error, okay? Okay, let's see. You can see rm cannot remove a directory. So what we need to do is that we need to come and introduce a flag, a -r flag, okay? If we add this -r flag to it, it will delete it. This is all we need to make it delete, okay? If we remove just this -r flag, it will delete it. However, I want to be able to see what is happening, what is being deleted, right? So if I run it like this alone, it will work, right? However, because I want to visualize, right? I want to add the verbose flag, right? I want to visualize, right? I'm using this term so that we'll remember. I want to visualize, right? I want to visualize it. So I use the rm-r, then I add v, okay? So if I run this, it will show me everything that is being deleted. That directory D is being deleted, directory C, directory B, in that order, right? So you see, you can see it tells me it removed directory 4, it removed directory 3, removed directory 2, then it removed directory D, removed directory C, removed directory B, removed directory D, then it removed directory 1, which is the parent of all, right? This is one that will remove the last. But if it's in terms of creating, this is the one it will create first because it is inside this one you have the next one, okay? But if it is deleting, it's deleting the one inside the most first, then deleting, right? Then when all children and grandchildren and have been deleted, that is when the main parent will be deleted, right? So you can see how it runs, right? So we are able to see how we can make a directory, delete a directory, and we've also seen how we can navigate through all the different directories, okay? So in the next session, we'll be looking at file maintenance commands, how we can create files, what we can do with files, look at permissions, and all of those good things. But I'll tell you, this is easy, right? This is easy. You just need to get used to it, play with it, no memorizing. Just try out your hands on the quizzes, try out your hands on the flashcards. They will stick. By the time you start testing yourself, even if you try and you don't get good enough score the first time, you try again, you realize that those ones, because all the quizzes, there'll be answers, even the ones you miss will provide answers so that you can always get them right when you attempt them again. Okay, so this is where we bring the class to an end. Do we have questions? Can leave a message in the chat if you want. Okay, are there questions? Okay, in the absence of questions, so let's have a great week. We'll get to talk. We'll get to meet in the next session. And if there are questions in the course of the week, please do not hesitate to reach out. I'll be happy to jump in and let's get things done. Okay? Thank you and bye for now.
Thank you.